Hello students, good afternoon. Good afternoon to all of you. Am I audible and visible? Can you all able to see me? Yes. Good afternoon, Rakshit Kumar, Madhukar Reddy, Jain Viroing, Vedant. So all of you can able to hear my voice and able to see the screen and me, right? Yes. Okay. Fine. So what we have studied yesterday in alcohols, phenols, and ethers, the classification, nomenclature, right? So yesterday we have discussed some introduction part of alcohols and phenols and ethers, and later on we have discussed something about the classification. First classification is based on the number of halogens. So let me have a summary of yesterday's session, and then we will go ahead with the next one. Okay. So first I have discussed about the classification of alcohol. Okay, and based on the number of OH groups present, these are the 4 classification, and then later on we have classified based on the hybridization. So we have to the monohydric system, and we have classified in according to the hybridization into sp3 and sp2. And sp3 hybridized system has 3 classification: alkyl, allyl, and benzyl. Okay, and sp2 has vinylic alcohol. Okay, this is all about the classification of alcohol. The next one is the classification of phenol. Okay, again it was classified into monohydric, dihydric, and trihydric. Then coming to ethers, there were 2 classification. One is simple ether or symmetrical, and the other one is mixed ether or unsymmetrical ether. Okay, then later on we have come to the nomenclature. Okay, there were 2 different types. One is common name and the other one is IUPAC nomenclature. So according to the IUPAC nomenclature, so for alcohols, we have to use the suffix OL, and for phenols, we have named accordingly. Okay, like ortho, meta, para for common name, and we used numbers to represent the phenol and its derivatives. Okay. So this is what we have discussed yesterday. And today we are about to discuss the nomenclature of ethers. Okay. So coming to the nomenclature of ethers, let's start with the common name. Okay. So the common name. In the common name, what you have to do, you have to give the name of the alkyl group or the name of the aryl group plus ether. Okay. For example, let me take CH3OCH3. So here I have 2 alkyl groups, right? Here I have 2 alkyl groups. So I have to name this as dimethyl because the name of the CH3 is methyl, right? So this is called as dimethyl ether. Okay. So name the alkyl group and add ether to it. That's all. So let me go ahead with one more compound. CH3OC2H5. So here we have 2 different types of alkyl groups. One is methyl and the other one is ethyl. So if 2 different groups are attached, then what you have to do, you have to go with the alphabetical order. So in the alphabetical order, E comes first, right? So you have to name this as ethyl, methyl, ether. Okay. Ethyl, methyl, ether. Next, the next compound is C6H5OCH3. C6H5OCH3. Okay, so here this group is called as methyl, and this C6H5, this phenyl, this ring is called as phenyl ring. So it starts with P. Okay, now according to the alphabetical order, M comes first. So it is called as methyl phenyl ether. Okay. It is also called as, methyl phenyl ether is also called as anisole. Methyl phenyl ether is otherwise called as anisole. So if you have a phenyl ring attached to OCH3, you have to name it as anisole. Got it? So I will go for one more. What is the name of this compound? Can you guys give a try for it? So here I have C2H5. What is the name of C2H5? This is called as phenyl. C6H5, this is called as phenyl. What is the name of C2H5? What is the name of C2H5, students? Or you give me the name of the compound. C2H5 is called as ethyl. So now you give me the name of the compound according to the alphabetical order. Which comes first? Students, none of you have got the answer for this? It is called as ethyl phenyl ether. It is called as ethyl phenyl ether, or otherwise called as phenetol. Okay. So if I have two C6H5 groups, what is the name? One ring is called as phenyl. If I have two phenyl, then it is called as diphenyl ether. Okay, diphenyl ether. Then coming to the next compound. So this CH3 is called as methyl. And CH3, CH, CH3. This group is called as isopropyl. This group is called as isopropyl. Okay. Now what we have to do? We have to go according to the alphabetical order, but here you should not take this I. Okay, you have to take the root word only. Root word starts with prop, right? So you have to take the letter P here. So M comes first. So it is called as methyl isopropyl ether. Okay. So coming to the next compound, here we have the phenyl group. This is phenyl. Okay. And here we have one group where we have three carbons. So the three carbons are arranged in a straight chain manner. So it is called as propyl. It is called as propyl. Okay. So pH comes first, then only PR. So it is called as phenyl propyl ether. Phenyl propyl ether. Do you have any doubts here? Do you have any doubt? Can you all able to understand the common name of ether? Shall I go ahead with the IUPAC nomenclature of ether? Students say yes or no? Okay. So now going ahead with the IUPAC names of ethers. So here we have to follow this skeletal structure. Okay. We have two alkyl groups or aryl groups. In that you have to take the smallest alkyl group or the aryl group. Then you have to add oxy and then only the bigger alkyl chain has to come. Okay. So it is very easy. I will tell you when I'm giving the examples. Listen, I'm going to take the same compounds, okay, which I have taken in the previous slide. So here we have CH3, CH3. Both the alkyl groups are same. So here you don't have to look into the smaller and bigger and all. Okay, you can take any one as the smaller part and the other one as the other part, okay, bigger part. So here I have taken CH3O, okay, first. So CH3O is called, CH3 is methyl, and if it is attached with oxygen, it is called as methoxy. It is called as methoxy. Okay. So smaller alkyl group plus oxy. Then I have a CH3 here, right? So it is called as methane. It is called as methane. So the name will be alkoxy alkane. Alkoxy alkane is the general name for IUPAC nomenclature of ether. Okay. So the name of this compound is methoxymethane. Okay. And in the second compound, you see, here I have one carbon and here I have two carbon. So the smallest group is CH3O. So it is methoxyethane. Methoxyethane. Okay. So here if you see, it is called as methoxy. This is taken as methoxy. And this part is benzene. Methoxybenzene. Okay. According to the IUPAC nomenclature also, it is called as anisole. Okay. It is called as anisole. And the fourth compound is, this is C2H5O. So it is ethoxybenzene. Ethoxybenzene. Got it? So moving forward with the fifth compound. So here if you see, in one alkyl group we have only one carbon, but in the other alkyl group we have three carbon. So if we have more than two carbon, we have to number it. Okay. So I am going to take that second alkyl part and I'm going to number from 1 to 3 like this. Okay. From 1 to 3 like this. Got it. Now what I have to do? Now I have to look into the alkoxy part. So alkoxy, that is CH3O. This part is attached to the second carbon of this chain. Okay. So it is called as 2-methoxypropane. In this chain we have three carbons, right? So it is 2-methoxypropane. Okay. So now I am going to take one new compound which we haven't seen the common name. This is the compound. So what is this? These two are the alkoxy part. So in this compound, we have two alkoxy part. Okay. And it is attached to the chain which has two carbon. So I have numbered this as 1 and 2. And to both the carbon, we have alkoxy. So it is 1, 2 dimethoxyethane. 1, 2 dimethoxyethane. Okay. Next, coming to the last. So here it is a cyclic compound. And these are the carbon atoms. Okay. These are the carbon atoms which is there on the cycle. And we also have some substituents attached to it. 2-methyl and 1-methoxy. Okay. So I have to number this, right? Number. So how to number this? 1 and 2 like this. Okay. So now this is methoxy and that is methyl. According to the alphabetical listing, you have to call this as 2-methoxy. M-E-T-H-O, right? And here M-E-T-H-Y. So methoxy has to come first. So it is 2-methoxy, 1, 1, because to the carbon number 1, we have 2 CH3. So it is 1, 1 dimethyl cyclohexane. The ring has 6 carbons, right? So it is called as cyclohexane. All right. Can you all able to understand how to name the ether? Do you have any doubts here? Students, can you all able to understand? Any doubt? Okay, okay. Thank you, Rakshit Kumar, for your response. What about others? Aishwarya, Bishan, Hemachandra, Jain Viroing, Madhukar, and Vedant. Do you guys have any doubt? Understood? Very good. So now let's go ahead with the third topic. Third topic means yesterday we have started with the classification, and secondly we have discussed about the nomenclature. Now I am going to discuss about the structure of alcohols, phenols and ethers. Okay, these three topics will come under the first main topic of this lesson. So let's go into the structure of alcohols first. So what is the formula for alcohol? ROH, right? ROH. If R group is methyl group, then the formula will be CH3OH. Can you give me the name of this compound? What is the name of CH3OH? Very simplest alcohol, right? What is the name of CH3OH? Yes, Vedant. It is methanol. It is called as methanol. Good. Yes, it is called as methanol. Now, oxygen has two lone pairs. We all know that oxygen can able to form two bond pair and they will have two lone pair of electrons. Okay. And because of this lone pair, the carbon-oxygen-hydrogen bond angle will be 108.9 degree. 108.9 degree. Okay. And the bond length means the carbon-oxygen bond length and oxygen-hydrogen bond length. Their values are 142 and 96 picometer. Got it? Bond length is not that much important, but you should know which bond will be having the highest length value and the one which is very small. Okay. So OH bond is smaller compared to CO bond. Now, the very important point that you have to keep in mind in the structure of alcohol is the hybridization of oxygen. So here, the hybridization of oxygen is sp3. And the hybridization of carbon is also sp3 because both of them have only the sigma bonds. Sigma means only single bonds around them. So the hybridization is sp3 in both the case. And the COH bond angle is 108.9 degree, which is actually less than the tetrahedral bond angle. So what is the tetrahedral bond angle? 109.5 degree is the tetrahedral bond angle. And 108 is less than 109, right? So why? sp3 hybridization means the geometry should be tetrahedral and the bond angle should be 109. But why it is getting decreased to 108? It is due to the repulsion between the lone pair of electrons and the bond pair of electrons. Okay. So here we have lone pair, bond pair repulsion, which is greater, and that's why the two bonds, they are coming closer to each other and the bond angle is reduced. Can you able to understand why the bond angle is decreasing? So if they ask you this type of question in a assertion reason type or reasoning out type, you should be able to tell. The answer is due to the repulsion between the lone pair and the bond pair. All right, understood? Shall we go for the structure of phenol? So in structure of alcohol, you should know the hybridization and the bond angle and why it is getting decreased. So these are the two important points you have to keep in mind. Then going ahead with the structure of phenol, we all know that the formula is C6H5OH. And here we have carbon, oxygen, hydrogen, and the bond angle that is created here is 109 degree. And this carbon oxygen bond length is 136 picometer, which is very high. Okay, 136 picometer. And the OH group is attached to sp2 hybridized carbon. This carbon is sp2 hybridized because it has double bond. Okay, if a carbon has double bond and the hybridization is sp2. Okay. And when you compare the bond length of CO bond length, when you compare the CO bond length of phenol with methanol, in methanol we have seen that the bond angle is, what is the value we have seen? CO bond angle here is 142 picometer. But in case of phenol, the CO bond angle is 136 picometer. Okay. So it is because the CO bond length in methanol is greater compared to the CO bond length in phenol. It is because the delocalization of the electrons in phenol. So here the pi electrons will get delocalized so that this carbon and oxygen will get the partial double bond character. Okay. In case of methanol, it is purely a single bond. But in case of phenol, they will have partial double bond character. So what will happen if the number of bonds increases? Okay, from 1 to 1.5, the bond length will decrease. Okay, the bond length will decrease. So this is the reason. The bond angle of bond length of CO decreases because of the delocalization of electrons of the phenyl ring. Got it? This is the structure of phenol. Next, coming to the structure of ether. So we all know the formula for ether is ROR. If I take the R group as methyl group, I will have CH3O, CH3, and this is methoxymethane compound. Okay. And as I have already told you, the oxygen will have two lone pair of electrons in it, and the bond angle that it makes is 111.7 degree. And the CO bond length here is 141 picometer. And the hybridization of oxygen and carbon both are sp3 because they have only single bond. Okay. But here, if you look into the bond angle, this is slightly greater than the tetrahedral bond angle, right? Bond angle is slightly greater than the tetrahedral bond angle, okay, which is 109.5 degree. Tetrahedral bond angle is 109.5 degree. So why it is getting increased? Due to the repulsive interaction between the two bulky group. So what they are trying to say is we have two CH3 groups. We have two CH3 groups. So they are bulky. So they will try to keep them very far away from each other. So if they try to keep them very far away, what will happen? The bond angle will increase. Okay, so that is why the bond angle is increased from the normal tetrahedral bond angle for ether. All right. For alcohol, it is getting less. And for ether, it is slightly greater than the normal tetrahedral bond angle. Okay. Can you all able to understand? Any doubt from the structure of all the three compounds? If you want to note down anything, if you want to make any points from the slides, you can stop me and you can write that. Okay. Fine. So I hope the structure of alcohol, phenol and ether are clear to all of you. So now we will go ahead with the next very important main topic of this lesson, which is the preparation of alcohols, phenols. Okay. So I will start with the preparation of alcohol. All the organic chemistry lesson, if you see, we will first study about the classification, then nomenclature, then structure and preparation, and physical property and chemical property. So this is the flow of all the organic chemistry lesson. Not only this lesson, for all the organic chemistry lesson, this is the flow. Okay. So we have completed the first three. So now we will go ahead with the preparation. So here we are going to prepare the alcohols. Okay. So we can prepare the alcohols from different compounds. Okay. The first is the preparation of alcohol from alkenes. Second is from carbonyl compounds. Third is from Grignard reagent. Okay. So we are going to take these three compounds and we are going to prepare the alcohols from this. Got it? So let's go ahead with the first compound, which is the preparation of alcohol from alkenes. Okay. From alkenes, from alkene compound itself, we can prepare the alcohol using two methods. Okay. One is by acid catalyst hydration and the other one is by hydroboration oxidation. Okay, so there are three main compounds from which the alcohols can be prepared. Okay, I have taken the first compound alkene, and using alkene itself, we can go for two ways. One is acid catalyst hydration and the other one is hydroboration oxidation. Okay, so let me take the acid catalyst hydration method first to prepare the alcohol from alkene. Okay, so by acid catalyst hydration. Here we have to, here from the name itself, it is understood that we are going to use an acid, okay, acid as the catalyst, and we are going to hydrate the compound. So what is meant by hydration? Addition of water. To which compound we are going to add the water? To the alkene, because we are going to prepare from alkene, right? So take an alkene, add water, use acid as a catalyst. Finally, you will get an alcohol. Got it? Got it? So we have two different types of alkenes, right? One is symmetrical alkene and the other one is unsymmetrical alkene. So if I'm going to take a symmetrical alkene, so let me take an example for symmetrical. CH2 double bond CH2. This is symmetrical. Okay, symmetrical means if I break this compound with respect to the double bond, it will give me two equal half. So this is an symmetrical alkene. So I have added the water and the H plus. So what is happening here? I am breaking this bond and this H2O has H plus and OH minus, right? So you can add H to one of the carbon and OH to the other carbon. So you will get the final product like this: CH3, CH2, OH, which is called as ethanol. C2H5OH, right? Two carbon containing alcohol. CH3, CH2OH. And the name of this alkene is ethene. It has two carbon, right? So it is ethene. So from ethene, I am getting ethanol. Now, if I use unsymmetrical alkene, let me take propene as an example. Okay. So here I have taken propene. Now what I have to do? You tell me. Why OH is added to the second carbon and H to the first carbon? Can you tell me why OH is attached to the second carbon? Can we add OH to the first carbon? Is it correct? Can we add OH to the first carbon? Is it right or wrong? Or is there any rule followed here for this addition? Very good, Rakshit and Bishan. It is according to the molecules are added, the ions are added to the double bond according to the Markov-Nikov's rule. Right? Very good. Exactly correct. So, what is Markov-Nikov's rule? Already I have explained in the previous lesson, right? So, we have to break the double bond. Okay? And here we have only one hydrogen and here two hydrogen. So, the negative part of the addition molecule have to go to the carbon which has less number of hydrogen atom. That is called as Markov-Nikov rule. Okay. So we are following that rule and that's why OH is added here and H is added here to give this product. All right. Can you give me the name of this compound? Name of the product? Can anyone give me the name of the product? The name of the reactant is propene. This is propene. What is the name of this product? We have three carbon containing alcohol. 1, 2 and 3. What is the name of this alcohol? What is the name of this alcohol? Yes, correct, Bishan. It is, yes, dear students, it is propan to all. Propan to all. So this is how we have to prepare the alcohol using acid catalyst hydration method. Now let me go for the second type, which is by hydroboration oxidation. Okay. Again, we are going to take alkene, but here the reagents are B2H6. B2H6. Okay. or BH3, B2H6 or BH3. Okay. And the second reagent is water peroxide and sodium hydroxide. Okay. So these two are the main reagent. Got it. If we use these two reagents, we will end up with an alcohol. And the name of this alcohol is propan 1-ol. Okay. 1, 2, 3, right? Propan 1-ol. So in the previous case, we have got propan 2-ol from propene. And here I am getting propan 1-ol from propene. So what is this? What is the feature of the reaction? What is the feature of the reaction? It is the opposite. The product seems opposite to the Markovnikov's rule. Okay. So in hydroboration oxidation, you have to use the anti-Markovnikov addition. And in the first case, you have to use the Markovnikov's addition. Okay. When I compare these two methods of preparation of alcohol, the second method of preparation, from this method, the alcohol is obtained in excellent yield. Okay. Alcohol is prepared in excellent yield using the second method. Got it? So how will you know? How will you know whether I have to use anti-Markovnikov here or Markovnikov? By seeing the peroxide. Okay. So if you see any peroxide with B2H6, then just by closing your eyes, you have to go for the anti-Markovnikov addition. Clear? Able to understand? So these are the two methods by which we can prepare the alcohol from alkene. Shall we go for one question? Are you all ready? Shall we solve one question? Any doubt so far? Students, am I audible? Okay. Yeah. Yeah. Okay, students. So we'll go ahead with the question. So I have taken one reactant and it is treated with B2H6 and the peroxide, water and sodium hydroxide. How will you get the product and what is the name of the product? And which addition we have to follow? Markovnikov or anti-Markovnikov for this? It is very clear from these two reagents, right, that we have to use the anti-Markovnikov rule. So what could be the product? So these are the two alkene carbons. And here I have one hydrogen because the carbon is having only 3 bonds. But this carbon has 4 bonds around it. So there is no hydrogen present. So here 0 hydrogen. And to this carbon, I have 1 hydrogen. Now, what is anti-Markovnikov? We have to break the bond and add the negative part of the molecule to the carbon, which has more number of hydrogen. So, if I compare 0 and 1, 1 is more. So, OH will go here and H will go here. Okay. So, I will get a product like this. We will get a 3 moles. We will get 3 moles because 3 moles of this compound will react. So, we will get 3 moles of the corresponding alcohol. Okay. So, here 1 and 2. So, it is 2-methyl cyclopentanol. 2-methyl cyclopentanol. Can you all able to understand this question? Can you all able to solve if some other reactant is given to you with this type of reagents? Able to understand the concept? Yes? Only Rakshit is saying yes. Bishan. What about others? Okay. Okay. Fine. So let's go ahead with the second preparation. The second method of preparation of alcohol is from carbonyl compounds, right? Carbonyl compounds. Alcohols from carbonyl compounds. So there are four very important carbonyl compounds: aldehydes, ketones, esters, and carboxylic acids. Okay. C double bond O containing compounds are called as carbonyl compounds, and these are the four important carbonyl compounds. Okay. So I'm going to classify this four into two categories. First is by the reduction of aldehyde and ketone. Second is by the reduction of carboxylic acid and ester. Okay. So these are the four carbonyl compounds from which we are going to prepare the alcohols using reduction method. Okay. So first let me go ahead with the reduction of aldehydes and ketones. Aldehydes and ketones, if they want to undergo reduction, we have to give the reducing agent to it, right? We have to give the reducing agent. Then only they will undergo the reduction process and they will be converted to alcohols. Okay. So the formula for aldehyde is RCHO. Formula for aldehyde is RCHO. Got it? C double bond OH. Both are same only. So aldehyde on reducing agent or aldehydes on reduction will lead to the formation of primary alcohol, and ketones on reduction will lead to the formation of secondary alcohol. Got it? So what is the difference between aldehyde and ketone? In aldehyde, you will have one alkyl group and one hydrogen. And in case of ketone, both the groups are alkyl groups. Okay, so this is a very important concept. Aldehyde leads to primary alcohol and ketone will lead to secondary alcohol. Now coming to the reducing agent. So who all can act as a reducing agent to reduce the aldehydes and ketones? Means for the very first one is hydrogen in presence of nickel, palladium or platinum as a catalyst. These three metals are the catalyst and hydrogen is going to reduce in presence of this catalyst. This is the reducing agent number one. And the second reducing agent is lithium aluminium hydride, LiAlH4. Okay. And the third one is sodium borohydride, NaBH4. So these are the three very important reducing agents which is capable of reducing aldehydes and ketones to alcohols. Okay. You should not forget these concepts. These are all the very important basic concepts of organic chemistry. Okay, which will follow you in the next lesson itself. So please have a look of it. Now, let me go for the examples. Let me go for the examples, or I will take each reagent and I will show you how they are going to reduce. Okay. So first, let me take the first reagent and I have taken an aldehyde, added the hydrogen in presence of nickel or palladium or platinum metal. And this will lead to the formation of which alcohol? Primary alcohol, right? So CHO will be converted to CH2OH. CH2OH. RCHO will be converted to RCH2OH. Okay. This is CH2OH means it is called as primary alcohol. Got it? And if I take ketone on the same reagent will lead to the formation of secondary alcohol. So it will lead to CHOH. CHOH means secondary alcohol. Got it? So this hydrogen in presence of nickel, palladium, platinum has some features. They not only reduce aldehydes and ketones, they can also reduce carbon-carbon double bond. They can reduce the aldehyde. They can reduce the ketone and they can reduce RCOCl. RCOCl means acyl halide. Okay. And lastly, it can reduce RCOOR. This is called as ester. This is called as ester. Okay. And this is acyl halide or acyl chloride. Okay. And this is ketone, you all know. And this is an aldehyde. And this is alkene. Okay. So the given reducing agent can able to reduce all the 5 compounds. Got it? Any doubt from this for anyone? No. Students, shall we go for the next slide? Any doubt from this? If you want to write this list in your notebook, you can take down. Shall we go for the next slide? Clear for all? Any doubt till this? Okay. So let me go ahead with the second reducing agent, lithium aluminium hydride. So take an aldehyde and add lithium aluminum hydride in presence of ether and H3O plus. So these are the side agents. Okay. Ether will act as a solvent and H3O plus is the secondary agent. So aldehyde will give primary alcohol and the ketone will give secondary alcohol. Okay. So now what are the features of this, other features of this lithium aluminum hydride? This compound has the capacity to reduce aldehyde, ketone and carboxylic acid. Okay. But it cannot reduce the double bond. It cannot reduce the double bond. This is the very important feature of lithium aluminum hydride. Got it? Very important feature of lithium aluminum hydride. And thirdly, they are very highly sensitive to moisture and it is a very expensive reagent. Okay, very costly. Okay, very costly reagent it is. They can reduce aldehyde, ketone and acid, but not the double bond, carbon-carbon double bond. Okay. This is about LiAlH4. Next, coming to the third one, sodium borohydride. So take the aldehyde and treat it with sodium borohydride and it will lead to the formation of primary alcohol and the ketone will give the secondary alcohol. Now the feature of NaBH4 is this is more selective than the previous one. Okay. And this one also cannot reduce the carbon-carbon double bond. Okay. But it has the ability to reduce other functional groups like halogen, cyano, they remain unaffected. Okay. Other functional groups like halogen, cyano remain unaffected. Okay. Halogen means fluorine, chlorine, bromine, iodine. Cyano means CN. So if these groups are present in the reactant, they remain unaffected like this carbon-carbon double bond and they will not be reduced. Okay. So this is more selective compared to lithium aluminum hydride. Then next, let me go for the second type, which is the reduction of carboxylic acid and ester. So first I have completed the reduction of aldehydes and ketones. Now we are going to enter into the carboxylic acid and ester. Okay, the first reduction is using lithium aluminum hydride. The formula for carboxylic acid is RCOOH. Okay, this is carboxylic acid. Let me take an example. So CH3 is taken as an example for alkyl group. So all the carboxylic acid will end with oic acid. Okay, it always ends with oic acid. So the name of this compound is ethanoic acid. The name of this compound is ethanoic acid. So all the carboxylic acid will end with oic acid. Got it? This is the carboxylic acid formula, and the ester is called as RCOOR. Okay. Again, if I take this R group as CH3, I will get this compound. Okay, which is an ester. Now, if these two compounds are treated with lithium aluminum hydride, both of them first will give the aldehyde. Both of them first will be reduced to aldehyde. And then on treatment with one more mole of lithium aluminum hydride, and they will give the alcohol, primary alcohol. Okay. As I have already told you, lithium aluminum hydride is a very expensive reagent. Got it? So first it will be converted to aldehyde. Then on reduction of aldehyde, it leads to the formation of alcohol. Got it? This point has some meaning. Okay. So since this lithium aluminum hydride is very expensive in nature, we cannot use this compound for all the reactions. Right? We cannot use this for all the reaction. We have to go for some other method or some other way to get the alcohol. Okay. And that way is called as esterification and then catalytic reduction. Okay. So in this method, we will not use lithium aluminum hydride. Got it? So take the carboxylic acid and treat it with alcohol. ROH is called as some alcohol. In presence of acid, what will happen? The H2O will come out, and this OR dash will go and form the bond with the carbon. And this is ester. So what I have done, from the carboxylic acid, using one alcohol and H plus, I have prepared the ester. Now this process is called as esterification. Preparation of ester is called as esterification. Then what I have to do? Catalytic reduction. We are going to reduce the ester using a catalyst. Okay. So hydrogen in presence of catalyst. Hydrogen is the reducing agent, and some other platinum, palladium, nickel catalyst can be used. If I use this, ester will lead to the formation of primary alcohol. It will lead to the formation of primary. This is not OH, this is H. This is H. CH3, CH2, OH, and also one more alcohol, R dash OH. So this compound I will get. Got it? So this will form one alcohol, and the other part, the two carbon system, will form another alcohol. Got it? So we will get a primary alcohol and other alcohol. So here you see, in these two steps, we did not use lithium aluminum hydride at all, but we have prepared the primary alcohol. Okay. So by doing these two steps, you can prepare without using the expensive reagent. Got it? This is all about the esterification and the catalytic reduction. Now I am going to give you one question, and you are going to find out A and B from this reaction. Can anyone find out the compound A first? So this is the reactant. This is the reactant, and it is treated with hydrogen in presence of nickel first, and it leads to the formation of A. Can you guess the formula or the name of the compound A? So all of you, please try for it. Find out A and B. So keep all the features which I have given for all the reducing agents and try to find out the answer for this question. You can give me the formula, or you can give me the name of the product. Okay. Anything is fine. So let me see who is going to give me the correct answer. Students, what about compound A? What is the name or what is the formula for compound A? It is very easy, no? We have a double bond and we have CHO group. What is the nature of hydrogen and nickel? Can this reagent reduce the double bond and the aldehyde, or it can reduce only the aldehyde? What is the feature of hydrogen in presence of nickel? Will it reduce both or only one? Hey, what happened? What is the answer? Hydrogen in presence of nickel can reduce both carbon-carbon double bond and aldehyde group, right? So what will happen if both are getting reduced? If I reduce this double bond, I have to break this and add hydrogen. If CHO is getting reduced, it will form CH2OH. So I will have CH3, CH2, CH2, and CHO will get converted to CH2OH, primary alcohol, right? So this is a product. It is butyl. We have 4 carbon, right? So it is N-butyl alcohol. And this compound, the reactant is called as crotonaldehyde. Okay. But if you use lithium aluminum hydride, we have studied just now that lithium aluminum hydride will not reduce carbon-carbon double bond. So only the CHO group can be converted to CH2OH. Okay, only the CHO will be converted to CH2OH. Got it? And this is called as crotyl alcohol. These are the common names. This is called as crotyl alcohol. Clear? Clear for all? So what we have studied today? We have discussed the nomenclature of ethers, and we have moved into the preparation topic. And first we have started with the preparation of alcohols. Okay, and alcohols can be prepared using 3 methods. One is using alkenes. We have completed that. Okay, and there were 2 classification, no? Using acid catalyst hydration, and the other one is hydroboration oxidation. And the second method is using carbonyl compounds by aldehydes, ketones, carboxylic acids, and esters. And the third is Grignard reagent. So this we will discuss in tomorrow's session. Okay. Any doubt from today's session for anyone? Do you have any doubts today? No? Okay, good. So thank you so much for attending the class. So see you all with the next topic in the next session. Okay. Till then, take care. Bye bye. So I have launched a poll for you guys.